Up until now, most of the equations that you've graphed have been lines. These are both examples, or this is a full page of examples of equations that are not lines. The first part, I'll do number 1 with you, and then the second one I will do number 4 with you. X squared plus 4x. They gave us values for x already. If x squared is 2, then it would be 2 squared plus 4 times 2. I'm substituting 2 for x. So that would be 4 plus 8 would make it 12. Do this. If I substitute 1 for x, then it would be y equals 1 squared plus 4 times 1, which would be 1 plus 4, which would be 5. If x is 0, then it would be y equals 0 squared plus 4 times 0, which would be 0 plus 0. So y is 0. If x is negative 1, remember to put your negative 1 in parentheses since it's negative, right? Y equals negative 1 squared plus 4 times negative 1. Negative 1 times negative 1 is 1. And then I'm just going to go ahead and positive 4 times negative 1 is negative 4. You could put 1 plus negative 4, but this is how I've always preferred to do it. So then y equals negative 3. Okay, let me come over here. If x is negative 2, then it would be negative 2 in parentheses squared plus 4 times negative 2. Negative 2 times negative 2 is 4. Oops. Should have just left it. Minus 4 times negative 2. So that's negative 8, so I did 4 minus 8. And it becomes negative 4. So negative 2 would be negative 4. Then we've got y equals negative 3 squared plus 4 times negative 3. That is 9. That's negative 12. So then we have negative 3. Negative 4, okay. Y equals negative 4 squared plus 4 times negative 4. Negative 4 squared is 16, and then that would be negative 16. Oh, which is 0. Again. We already had a 0. That's unusual to have the same one more than once. Negative 5. Negative 5 squared plus 4 times negative 5 is 25 minus 20, or plus negative 20. Gives us 5. And finally, negative 6. That would be 36 minus 24, which gives you 12. All right. So let's plot these points. All right, so we have 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Just so you know, anytime you have an exponent, it will not be a straight line. 1, 5, 2, 3, 0, 0, negative 1, negative 3, negative 2, negative 4, negative 1, 2, 3, 1, 2, negative 4, wait, 1, 2, 3, 4, 0. Need to work on that dot. Negative 5, negative 5. Wait, 1, 2, 3, 4. Negative 5, positive 5. 1, 2, 3, 4, 5. Negative 6, 12. Okay. Take a moment and make sure your points match up with mine. And this is one instance where a ruler is not going to help much, because it's not a straight line. You just connect point to point. Like that. I should just keep that kind of going. Using a ruler on a parabola, you know, one with rounded parts, is your choice. You don't have to do that. It's optional. Let's be careful with the directions. Each of these graphs has two separate parts. To make sure that you graph both parts, choose both positive and negative numbers for x. I always like to start with 0. We'll do 1, 2, 3, and then I will do negative 1, negative 2, negative 3. How about I do 4, hello, and negative 4. In this equation, we have the absolute value of x divided by x. So it'll always be, so the absolute value of 0 over 0 the absolute value of 1 over 1 is 1. This is interesting. The absolute value of 2 over 2 is 1. The absolute value of 3 over 3 is 1. The absolute value of negative 1 over negative 1. So the absolute value of negative 1 is positive 1 over negative 1. The absolute value of that becomes positive. So now you have 1 divided by negative 1. That would give us negative 1. So let's do this one. The absolute value of negative 2 over 2, over negative 2 is, the absolute value of negative 2 is positive 2 over negative 2. That becomes negative 1. I'm seeing a pattern. So the absolute value of negative 3 over negative 3 becomes 3 over negative 3, which also becomes negative 1. So then we have y equals, oh, almost forgot. The absolute value of negative 4 over 4, that becomes, sorry, it's negative 4. That becomes 4 over negative 4, which is then negative 1. And then y equals the absolute value of 4 over 4. Well, that would be 4 over 4, which equals 1. That's negative 1, and that's 1. Page 20 is a little interesting. We are graphing equations that only have one variable. So for example, this one only has a y variable. The equation is y equals 2. What they're wanting us to do is to create another equation that will be equal to it, but also have an x in it. And the only way you can do that is multiply the x times 0. That's the only way that your y will always be 2, because you only want to add 2. So for example, in this, if x is 5, 5 times 0 is 0, plus 2 is 2. If x is 3, 3 times 0 is 0, plus 2 equals 2. 0 times 0 is 0, plus 2. Negative 6 times 0 is 0, plus 2 equals 2. So no matter what you put for x, you'll always have this 2 left over. So that's why this works. When you graph it, y equals 2, so y is always 2. Graph each equation by writing an equivalent equation with 2 variables and then making a table of solutions. Well, we don't have an x, so x is going to be 0. You have to multiply it times 0. That's the only way. So 0x. And then it's going to be, you can either put plus negative 3 or minus 3. They're both the same. So now your y will always be negative 3. And if you don't believe me, you can try. I'm going to do 1, 3, 5, negative 2, negative 4, negative 6. 1 times 0 is 0, minus 3 is negative 3. 5 times 0 is 0, minus 3 is negative 3. Negative 4 times 0 is 0, minus 3 is negative 3. No matter what you put, as long as you multiply it by 0. And when you graph it, 1, negative 3, then we've got 3, negative 3, then I went to 5, negative 3, then I did negative 2, negative 3, 4, negative 3, negative 6, negative 3. So now I can draw my line. There. At number 4, y equals 0, so y is always going to be here. So you could put 0 times x plus 0. Well, so we'll do, let's see, 0, 1, 3, 5, and then -2, -4. But 0, 1, 0, 3, 0, 5, 0, -2, 0, -4, 0. And here is my line. They already did the equation for you on number 1, so all you have to do is fill in values and graph it. Then number 5, you'll actually have to write your equation, but you can see exactly, I hope, what the equation will be like given the examples that we did. Go back and do page 19 and page 20.